Hello again, class. Today we're going to take a look at a practice assembly problem. In this case, I have a pendulum that is composed of a bottom, two links, one pendulum, two pins that are slightly longer, and two pins that are slightly shorter. And we've got them some kind of nice colors here. We can see with the different organs. We know we're in millimeter gram second. So let's go ahead and create a new assembly. And we know we want this to be in millimeter gram second. Oh, it wants us to open a part. I'm just going to hit cancel for a second here. So I can change this to millimeter gram second. I haven't downloaded the parts yet, so I'll go ahead and download the parts. I would always recommend that you unpack these files for the zip, if you're given a zip file, somewhere into your computer. I usually recommend using a new folder. So I might make this go into a folder on my desktop or a folder somewhere else on the computer. In this case, I'm just going to put them in the downloads folder. And that works fine for now. So here, I'm going to have the bottom as the first part. When I'm working in Solidworks in an assembly, I would always recommend that you have the first part be the part you want to have fixed. And typically, if you're given a part with a origin in a specific position, if you bring in the first part and then click on this green check mark, don't click on the screen, click on the green check mark. That's going to make the origin of that first part align with the origin of the assembly. And most of the time that locates the origin in the position that you want for the assembly process. We can check and make sure that's correct by looking at our diagram here. We can see that the origin is in the middle of the bottom of the part, and it's got the Y in the vertical direction, the X in the right direction, which you can see here, Y up, X to the right. And if I look at it from a different view, so here you can see the Z is coming kind of down to the left, here it's going down to the left. So I'm very confident that the orientation of this part is correct, and it's fixed so it can't be moved around as I add other components. Now I have two links, so I'm going to bring in two links. 1 and 2. I'm just dragging and dropping these from slightly off screen here. I have one pendulum, so we'll bring in one pendulum. We have two long pins. Let's bring in our two long pins. And we have two short pins. So I'll bring in our two short pins. And that should be all the parts that we need. We can get that out of the way. The assembly is in the following conditions. So the bottom origin is consistent with the assembly origin with the axes aligned. We already checked that, so we're good there. The links are concentric with the holes in the bottom. So assuming these holes here, and are connected with the long pin. So the long pin connects the links to the holes on the bottom part. So let's go ahead and put those in place. I'll use the mate tool. I'm going to start with concentric. And then I want this to be lined up on the side. So I'm going to check and see if these pins are just kind of the right length to fit in perfectly. Looks like they are, so I'll accept that and then do the same thing on the other side. So again, adding a concentric mate, then adding a coincident mate between the face of the pin and the face of the bottom. Those look great, just like that. And then we'll do the same thing for the links. So I'm going to put that in place there. Again, that's just a coincident relation. Move it a little bit out of the way. Not sure what I did there. I'm going to use Control Z. I'm just going to add the mate again. And probably I didn't click on the green check mark before I tried to move that, and it changed the type of mate that I was adding. So another thing to be careful here, if I click, then it makes the selection. If I drag, it does not. So if you hold the mouse down and drag it around, it's not going to select. Let's allow you to move things. So I'm going to click both those, make those concentric. That looks good. Drag this in a little bit. It looks like that doesn't fully fit the slot there. It looks like it's probably centered in that position. I haven't gotten to that point in my instructions yet, so I'm going to keep going before I add any more relations there. The holes in the pendulum are concentric with the holes in the links and are connected by the short pin. So kind of like I just did for the bottom, I need to get this pendulum in place. So let's add some more concentric relations. There's concentric there. Let's check and see if this pin fits just perfectly in the pendulum. Looks like it does, so I'll accept that. And then we'll do another one for the other side. So again, concentric there. And we'll do coincident on the face of the pendulum to the side of the pin. That looks good. And then we'll make the pins on the pendulum concentric with the opposite ends of the links. I'm going to accept that. Again, I'm going to move this around a little bit to kind of get closer to where I want it. Depending on where you click on these, you can have a hard time kind of moving them in place. If you're having a real hard time with that, it's not getting to where you want it, just try and grab someplace else. And usually you can get it or somewhere kind of oriented close. And then once you're reasonably close, you can go ahead and continue adding more mates. You do want to make sure you're getting this into a position that kind of makes sense with what you have. So this makes kind of sense to pull these things together and to move them into a place where the configuration isn't going to get messed up if I add additional mates. It will define the alignment of the mates based off the position of the parts. So if it's flipping your parts around and doing them all kind of weird, check and make sure that you have the appropriate set of constraints, or maybe you need to flip them using kind of the options that show up down here. That looks pretty good. All parts are centered in the Z direction. So I need to have something that's going to center these parts in this plane. I like to look and see what I have in terms of reference planes. So here I have a front plane and a front plane because this is my bottom part. Those are aligned. On my links, again, I have a front plane that's going to the middle of the link. So if I want those middles to line up, I can control click both of those. And then again, we can add the mate to make those middles concentric. And that's going to keep those lined up. I can look for a similar thing on the opposite link. So there was link 1. Let's go to link 2. Again, it has a front plane and the front plane of the assembly. I'll accept that. And can I do the same thing for the pendulum? We'll look at the pendulum. Let's hide the links so we can actually see all these. So this is the pendulum's reference planes. Again, it also has a front plane that goes through its middle. So again, I can put that on the front of the assembly, and that's going to define the position of all these guys in kind of this left-right direction. So the only thing that's left is kind of the rocking movement of the pendulum, which makes sense because if there's a pendulum, I do want it to be able to rock back and forth. So that looks good. I do need to get rid of that last kind of degree of freedom, that movement of the pendulum. And so to get that fully defined, I need to add some more constraint on here. And the pendulum is vertical aligned with the Y direction. So I want this pendulum to go straight up in the Y direction. And to do that, I think I'm going to go back to the reference planes of the pendulum and see if there's something I can define as being kind of vertical. So there's the right plane of that. Again, if I align that with the right plane of my assembly, then that's going to be vertically aligned and fully defined. So let's go ahead and mate those two. And that should give us a fully defined pendulum. So we can look through here. Our bottom is fixed. That's good. We know it's in the right position. The links are both fixed. They're both fully defined. With the mates, I can't move them. Pendulum is also fully defined. The only thing that's underdefined is my pins. But if I try and move or rotate them, really the only thing I can do is I can rotate them about their origin, which isn't going to change their center of mass location. So I'm okay with leaving that underdefined. So, all right, this thing wants to know the center of mass position in the Y direction. So I'm going to come into my evaluate tools and look at match properties. I got to rebuild, probably want to save this as well. But I have the center of mass in the Y direction as being 133.5. Check that versus the options here. I do have an exact match, so I'm pretty sure I've got that correct. And I can go on to the next part. Next part here, it says using the assembly from the previous question, modify the assembly with the following conditions to remove the vertical constraint from the pendulum. So I'm going to come to the coincident that I added between the right planes, and I'm just going to suppress that. That's going to remove the constraint keeping these vertical. So now they can rotate. And I need to add a 2.5 degree angle constraint between the right plane of the pendulum. So here it specifically says to use the right plane of the pendulum and the right plane of the assembly. And again, that makes it very obvious to what I need to do here. I need to go to the right plane of the assembly, because it's right here, and the right plane of the pendulum. So I'll click on both of those. And I will go into assembly mate. So this is pretty much the same mate I had before, but this time I want to make it an angled mate of 2.5 degrees. On these, be careful about directions. So you notice that mine is going in the negative X and theirs is going in the positive direction. So I'm just going to flip that dimension. So now mine is going in the positive X direction and theirs is going in the positive X direction. That's pretty good. We'll add that. And now I should be able to, again, evaluate the center of mass of the assembly. So I'll go into evaluate center of mass and I get 135.38. I'll copy that and paste it in. And that should be good. One quick note on this is that if I click on one of the parts and then click on mass properties, it will give me the center of mass relative for just that one part and not the whole assembly. So before you do mass properties on the assembly, make sure you don't have anything selected and make sure you have the assembly here as being shown as what it's giving you the properties for, unless the question is asking specifically for what the center of mass of a specific component is. So hopefully that's helpful. Thanks for watching, and I'll see you all again soon.